Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at question 6 from the 2020 Math Methods External Exam, paper 2. Now you would have noticed with all the videos on the channel I've started splitting them up into individual videos. That way I can go into a bit more depth on each question and also gives you guys a bit of variety in terms of study material. So if you only struggle with question let's say 6, 8, etc., you can go watch those on the channel. If you guys need a Methods External Exam bundle pack, the link is in the description below, so go get your download. Otherwise, with this one here, if you have any questions at all, leave something in the comments, and then yeah, let's just get straight into it. So question 6. Oil is leaking from a tank at a rate of, and we're given a function here, R of t, at liters per hour, where t is in hours. Determine how much oil leaks from the tanker to the nearest liter from time t equals 0 to t equals 10. Okay, first of all, this is a rate, okay? This is the rate at which the liters is changing. So if we want to work out how much has gone out, we need to work out how much has pretty much gone at the start and how much has gone at the end, okay? So here, because R of t is the rate at which it's leaking, we need to pretty much work out we need to work out pretty much a function that if you chuck in a t, it tells you how much is in there, okay? So here we would have to integrate that, okay? Because the opposite of, this is like a derivative here. In order to undo a derivative, you have to integrate it with respect to its variable. Now here, if I want to work out how much oil has leaked out here, let's say this gives us R of t, or if I chuck in a t into here, it gives me how much was pretty much out, etc. I would need to work out what is R of 10 minus R of 0. So the difference between at t equals 10 and t equals 0. Now there's a really easy way to do this with this question here. You just set it up in one big integral. So you would integrate R of t, so you'd integrate it with respect to time. So you'd be integrating this guy here, except you would put bounds on it, because you're looking between t equals 0 to t equals 10. So it'd be 0, and then be 10. So this gives you R of basically 10 minus R of 0. So here all you'd have to do is like integrate this thing here. Now when you integrate that, you could use your calculator or you can do it by hand. If you're integrating this guy here, we know e doesn't change, but you have to divide by the differential of this, which would be negative 0.2. So this would be 900 e negative 0.2 t over negative 0.2 between 0 and 10. You then chuck in the 10, so you have 9,000 e negative 0.2 times 10 over negative 0.2. Then you would subtract, chuck in the 0, so 9,000 e negative 0.2 times 0 over negative 0.2. You would then chuck that into your calculator, okay? So realistically you could have just chucked the whole integral in, but that's the working if this was like a short response question. Now if you chuck this in, I'll just tell you what it gives in a second. Between 10. So we get approximately 38909.9. So here we've got to look, alright, what number matches that the best? And I think A matches it the best. You just have to round this guy up and that'll turn into a 10 anyway. So A is your correct answer for question 6. I think this is a pretty easy question. The thing you got to look out for is the wording here when they say a rate, liters per hour. That means it's a derivative. So to undo a derivative, you have to integrate. And because they want it between two bounds, you can just set those as the upper and lower bounds respectively. But if you have any questions about this one here, you need to take a look at applications of differentiation integration a bit more, and who knows, you might need the Methods External Exam bundle pack. The link is in the description below. But otherwise, if you have any questions, leave something in the comments, and if you want the link to the full exam, it's in the description as well. Alright, I'll see you guys in the next video.